Yeah, Scott mentioned Mike Wilson, data collection lead with Deveron, one of the senior agronomists as well. Today, want to talk about soil sampling with you all. Going to focus mainly on zone creation, data management, how to create the right resolution, how to get the work done in the field, and then most importantly, analyzing the results and getting the stuff back to the customer. I'm not going to focus a lot on the actual lab results themselves. We kind of rely on our lab partners to do that with us in partnership. But if you all would like another webinar or something along the lines of explanation of the actual numbers in a soil test and optimum values and things like that, please throw that in the comment section or in a question so Scott can see that. And if the response is strong enough, we can host another webinar on just diving into the actual numbers and results on the report itself, because that's often misunderstood or confusing as well. But we'll definitely take a look at the things ahead of the soil lab and then after, and how we can create value for the customer, and how we use precision ag and all this data floating around to make smarter decisions and more profitable decisions for the farm customer and our businesses. So with that, let's get started. So why soil sample? When we think in terms of general, we have to create value for the customer, and we want to really create more bushels or more profitability or whatever the goal is of the farmer we're trying to figure out. We need to create that agronomic foundation so that we can do that. We need to have a baseline so we understand what soil test levels are and what the yield is on top of that soil test, so we can begin to understand the correlation between both, so we can begin to make smarter decisions. We need to stop avoiding blind decisions. I'll show some slides here next, showing some very alarming trends across North America that we need to stop as farmers, as consultants, as ag retails. We need to help our customers make better decisions and apply the right amount of fertilizer in the right places. To do that well, we need to measure things so that we can manage them better. Soil testing is the only way we can physically do that today. And the more we do, and the higher the resolution we do, the smarter, more accurate decisions and the less risk we take. And we make ourselves defensible against regulations, against environmental concerns and things like that. Today, if you're a customer or any of your customers don't have a soil test, you're indefensible against anything that comes at you. You can't prove the right amount of fertilizer put down. You don't know, there's just nothing to prove what you're doing is sound and agronomic and the right choice. And lastly, we need to be able to create profitable recommendations, right? That's what it all boils down to, creating that value to the customer, helping them understand why they're putting the fertilizer where they are, and getting a positive response back and a positive ROI at the end of the season. So when we look at some numbers, now this is work the IPNI does every few years. You can see this with the last major report was in 2015. I'm actually fairly excited and anticipating we'll see another one out sometime in the early 2021, showing the 2015 to 2020 results. And I'm curious to see how the trends have changed. But if we look at these numbers, some things really start to jump off the page of this. So this map on the left shows us the change in the average soil test P from 2010 to 2015. So the green numbers are the states and provinces that actually gained in their average phosphorus level. The red ones are the states and provinces that are losing, going backwards, not applying enough fertilizer. When we look at the map on the right, that shows us the percentage of samples taken in each state or province that are at or below critical soil test level. We've got some states in the 50s, 60s, 48s, 84, 83, some provinces in the same ranges. When half of our soil test levels coming in for phosphorus are below critical soil test levels, that's alarming. We're seeing yield drag and negativity, some negative yield effects because of that. When we look at potassium, same set of maps, we see the same thing. Some alarming negative changes, some positive ones, and some really decent declines or percentages, I should say, of soil tests below critical level, right? So this is aggregate data from all the labs that the IPNI puts together and gives a report out showing trends in fertility levels across North America. And you know, it's quite alarming. We need to do a better job as an industry, and we need to help our farmers understand why. Now we need to do that in correlation to 4Rs and some things, so make sure we're doing it in a agronomic way, that we're respecting regulations and we're not negatively affecting the environment. But we all know as agronomists and customers, as yield goes up, the amount of fertilizer applied to the land has to go up as well. We just need to do that in the right way. And that's where precision ag and some of the tools we'll show today allow us to do that. So we're not over applying on sensitive land, and we're not over applying on areas that are already high or excessive. And we are focusing our input dollar and our fertilizer application to the areas that need it and require it to increase farm profitability and yield. That's the key to everything we need to do. So when we look at how much fertilizer does one soil sample represent, or how much do we need to apply to a farm, you know, let's take a look at a 3-year rotation: corn, soybean, and winter wheat. Just threw in these bushels for some rough numbers. Obviously, this changes depending on where you're at in North America and what your overall bushels are. But you know, we're looking at 365 pounds of actual nitrogen, 240 pounds of actual phosphorus, and 330 pounds of actual potassium required just to grow that crop over that 3-year period, right? So when we break that out from actual to nutrient, we come up with 550 pounds of potash, 462 pounds of MAP, and 683 pounds of, I used urea in this case just to give a general requirement. So when we extrapolate that out over a 100-acre field, you know, we come up with some pretty big numbers. And we're looking at just under $45,000 Canadian and just under $40,000 US for a fertilizer investment over 3 years. That's a big number. I mean, that's a large part of our input expense. And, you know, we need to be making sure we're spending that money wisely and putting it in the right spot and making sure we're obtaining the maximum value we can from that investment. If we look at it based on resolution, if we're a customer that's taking one soil sample on a field or even bulk sampling at a 25-acre resolution, we've got over $10,000 of fertilizer input investment riding on one soil sample. And depending on the variability in your farm, are you okay with that? You know, there's a lot of change and a lot of things happening on that soil. And if we get it wrong, there's a lot of risk and a lot of dollars that can potentially, you know, not be used profitably. You know, as we increase resolution, we can see we start to really tighten up that risk factor and how much fertilizer, you know, is in jeopardy based on the resolution we're sampling. So when we think about current or historic farming practices, and current in some places too, where we're applying straight rates to a field, right? If we're looking at a 200 bushel corn crop on this line and we're applying all of our nutrients, seed, everything, but for this instance, nutrients at that 200 bushel level, we're only applying this small percentage, our medium productive areas, the average areas in the field, properly, right? Everything to the left of that field average, we are over applying fertilizer. We're applying more fertilizer than yield. And over time, if we continue this trend, we're actually building our worst productive soils. And they're not poor producing because of fertility, because they're already too high. They're poor producing because it's a sand knoll, or it always floods, or, you know, 90% of the time it's a water issue, but it's a droughty area that dries out and burns up in the summer. Whatever the reason is, it does not perform. We're over applying, we're wasting money, and potentially having an environmental impact. On the flip side, everything to the right of the average is areas where yield is high, and we're actually under applying nutrients. So as crop yields go up and we're not adjusting this level bar, we actually wind up with more of the field under fertilized. and under application rates. And that's the trend we're seeing from those IP&I results. Yields are going up. We're not adjusting or properly changing our fertilizer rates. And we're seeing those high testing soil areas become smaller and smaller and smaller. And we're seeing our low testing soil areas get larger, larger, and larger as we improve yields and change things, and as genetics change and become better in some of those more stressful areas. So we really need to watch this, and we need to increase our fertilizer rates in these high yield areas to get our soil tests away from critical level and to start getting some of that yield back and regain some of those bushels that we're leaving on the table. So that's where our opportunities are, the right and left. And data management and precision ag really help us understand where those areas are and allow us to focus on applying product properly in those areas so we are being environmentally friendly. When we do that, our input line matches our yield line, and I even increased the yield here to 250 bushel as an average. And this starts to really fall into that 4R nutrient stewardship guidelines, where we're not over applying in our poor yielding sensitive feature areas, and we are applying the right amount of bushels or fertilizer in those high yielding areas where, you know, we can push a little harder and we can get some more value out of it, ultimately making the best bang for our input dollar we can get to drive profitability on the farm. So I want to now swing into the accuracy part of soil sampling and have a discussion around, do we zone sample? Do we polygon sample? Do we grid sample? What's the right resolution? What's the right strategy? What's the right method of soil sampling for my farm or for my customer's farm? I'm a firm believer in polygon-based sampling. I like the way that works, and you'll see some of that through the presentation. But all methods do work, and all methods are acceptable. The key is picking the right one that fits your farm and fits the variability that's on your farm. That's the most important. So here's an example we've just done for a customer in the last couple weeks. This is just a bare ground soil map that you can find from Google Earth. Nothing fancy about it, but you can really see there's some drastic changes in soil type as we move across this farm. Some different tillage practices or cropping practices here. So you can, we've got some corn stubble still standing and either some soybean ground that's been worked, or we can still see the soil underneath of it. Nonetheless, there's a little bit of difference there, but you can still see the variation quite well. When we look at the yield map from this year on top of that data, the trend's real. I mean, it's a no-brainer. The lighter textured soils are lower yielding areas. The heavier ground or darker ground, usually meaning more organic matter, more water holding capacity, so on and so forth. We start to see, the higher yielding zones and areas like that. So definitely needs to be different management practices on this farm. These soils do not perform at the same level as these. We need to manage those areas different. We need the soil sample to best understand what's happening on those areas so that we can take it to that next level. So when we look at grid sampling, we do our typical 2.5 acre grid, a point every 2.5 acres, spread randomly across the farm based on the grid pattern. That's the typical type of results we get. When we contour in the GIS software, this is the type of map that happens when we create the data together, and the data weights each point based on its distance and value from all the other points around it. And we get a map that looks like this. In the top section, it's not terrible. You can see how the CEC, this is a CEC value, both top and bottom. You can see how the CEC values do tend to follow the trends on yield, and we get a relatively decent response. When we get to this piece, not so much. We're missing a lot of this variability, and you can see the variability is more defined and more specific. And when you start to look at the dots, you begin to understand why. We've got 2 points here, 3 up the middle. So that point was in a yellow to green area. Yellow to green, we'll get over this. It just missed that red area, and then we're way over in here. So that area here is right in between those dots, and the computer doesn't pick it up. So we miss it and we lose that. Same thing if we look in the top corner. That high yield zone goes right up into here. Yes, we've got that CEC here, but you can see with this dark soil type, it got missed by that point. So the computer doesn't understand that, and it doesn't extrapolate the data properly. right? So again, depending on the variability in your field, grid sampling works well, but also could leave some things to be desired, depending on what your end goal is and what you're looking to do. Now, polygon sampling, this, I believe these are 5 acre zones. So you're going to have, it's actually going to cost less than the 2.5 acre grid, because the amount of soil going to the lab is half, and the time in the field sampling be a little bit quicker, but basically would be a wash. You could draw 2.5 acre polygons if you preferred, and tighten the resolution up even more, and have a very similar to the exact same expense as you would have with 2.5 acre grid. But look at the difference you get with data. Now, there's no computer extrapolation here. This is, you take 12 cores across each zone, and the average of the zone is what's represented on the map. So you can begin to see how the CEC values begin to match and change, and they do fit the yield zones much better. Okay, so that becomes important when, if we're just looking for some general fertilizer recs and we're just looking to change the farm in general and look for an improvement, grid sampling works well. But when we take it to the next level, and some of the more interesting tools we'll show at the end of the presentation around trying to calculate some ROI, we really need our soil sampling resolution to match our yield goal on top, because that's what drives the knowledge, and that's what drives the statistical analysis, and it really starts to add up. So, if you're blessed with a field that's flat, black, and beautiful with not a lot of variability and everything's great, grid sampling or some lower resolution type sampling works well and amazing. You'll get excellent results. But if you also have a farm that has lots of topography, lots of rolls, lots of different types of soil in it, unfortunately, you're going to have to spend some more money in sampling and better understand that variability and to get to that same level and that same profit that you're looking for. So kind of the same example again, but this is the farm we'll probably use for the rest of the presentation, kind of as a case study to kind of show the value and understand and work through. So in the center here, we've got 4 years worth of yield. And you can see there are variations from the years, but in general, the same trends are real. High yielding areas with 1, 2, 3 knolls and a really low spot that needs a little bit more drainage. We see that time in, year out. That's how this farm performs. It's very predictable. It's real. The bare ground image with the zones over top of it, and obviously the yield map with the zones. I love using yield as the starting place when creating zones, and then using an elevation layer, a bare ground layer. If you have a Varus or some other types of data, that layer as well, to really tweak and manage those zones into something that's going to work and drive success for the customer and for the operation. But you can really see that soil type is the main driver of that yield, obviously, and then we go from there. So when we start looking at the actual resolution itself, there's many different ways to look at it. So and there's many different sampling practices in the marketplace today as well. There's sensor-based samplers, so soil optics, Varus, EM38 sleds, things like that. Then we get into our traditional grid sampling, our traditional polygon sampling, and then there's even zone sampling, where we take an image or a yield map and we contour it and we come up with some results. So let's look at some of those and talk through what you're getting when you purchase it, because it's very important to understand the approach that the soil sampling operation is going to provide to you, so that you can make sure it matches the end goal and what you're trying to solve on the farm. Some work very well, some don't, based on your goal, and they all have a different value, a different price per acre. So matching that to your economical budget and to achieve your goals is crucial in your satisfaction at the end of the day. So this map on the left is obviously a yield map, and I have on top of it the 1 acre grid, or sorry, the 1 acre polygons that were drawn for this farm based off of bare ground, elevation, and yield. The map on the right is an actual soil optics layer, a true sensor-based layer that's measuring the soil variability as the sensor drives across the farm, similar to what a Veris cart would do in measuring EC. This is a CEC cart. Soil optics is different though, because it takes it to a next level, and it also gives you a map like this for every single nutrient that you request from the lab. So from phosphorus, potassium, all the way to all your micros would give you a individual map. So very, very high level of data. Probably one of the more expensive options in the marketplace, but you do get what you pay for when it comes to soil sampling resolution. And depending on your goals or your customers' goals for their farm, yeah, might be something to consider. So let's start with the basic 25-acre bulk or grid. You know, we split that 100-acre farm into 4 squares. Based on the data we've collected, you know, this is what that would look like. This corner is obviously the heaviest soil, and this corner is the lightest. It's just an average of those 4 corners, and you really begin to see how much of the variability we're picking up. You know, not a lot. Does that give you a baseline? Does it give you some trends to follow over time? Am I going backwards? Am I going forwards? Sure, it does. Is that valuable? Yes. But is it really getting you to that next level? Is it really helping you to manage the farm differently, other than just see some, you know, a baseline trend over time? You know, not really. We go to 10-acre grids. It starts to get better, but still not overly impressive on, you know, the amount of data it's getting back. 5-acre, you know, we start to see things improve a little more. 2.5-acre, we're starting to see some trends, but it's not till you get to that 1-acre grid that you actually really start to see the different veins of soil going across it. And it's even arguable at that point, is it really even at the level of what we were seeing on that first soil optics? And you know, with 2.5-acre grid being most standard for precision ag soil sampling across North America, you know, I think there's room for improvement there. I mean, it's a great practice, and it is the industry standard, and it does work very well. But as we learn more and as we begin to see some of these statistical analysis tools come to the marketplace, you know, it leaves us a little bit wanting. A lot of customers are moving to 1-acre grids because they do see the problems with the 2.5, or that's if they want to take that next step, but the price becomes very challenging and more than most customers are willing to bear, just because of the sheer amount of soil that has to go to the lab. So if we begin to look at polygon-based sampling, and we make those polygons or zones at the 10-acre size, you know, sure, that's probably a little better. At least we're getting some trends in poor yield and high yield than we would get with 10-acre grid, but still a very big average. And, you know, this would be very kind of similar to like high ground, low ground type sampling. 5-acre zones, we start to see trends. 2.5, very good. You know, now we're seeing the different soil test layers, and they are matching the yield, and we're getting the high knolls, and we're getting the low ground pockets, and we're starting to see it. If you go to 1-acre zones, it's almost comparable, if I go back and forth quickly, to the sensor-based approach. There's not a lot of difference, but 1-acre zones is expensive, very expensive. So, you know, the difference there is enough to make us start considering some of these new sensor-based tools, because they are starting to emerge and they are starting to do a very good job, you know, across the industry on how that works. So when we look at them all in one page, now these are Canadian pricing, but it does give you kind of the trend across the page, and you can see how as resolution increases, so does the price. And the large driver of that is just the sheer amount of soil that has to go to the lab. So when I look at that, you know, I try to figure out value for the customer and where are they getting their best bang for their dollar. And it's in that 5 to 2.5 acre polygon size, in my opinion. This sensor technology is really coming, and I leave that question mark beside the best value because this has me interested. We are working with some sensor-based companies now, and I'm impressed. And when we can get that sensor technology for just a few dollars more than we can get 2.5 acre, you know, if a customer begins to tell me he wants to start variable rate seeding, applying some nitrogen, fungicide scripts in field variable rate, and there's some data layers in these sensor things that we can't get from regular soil sampling. Now I'm interested. Now this $25 starts to pay, and I'm sold, right? So depending on the goals of your operation, pick the right soil sampling method and resolution that best suits your or your customer's operation. So when we look at the three different types, again, we really need to know the value, and we really need to know what we're purchasing. So if we're purchasing true zone sampling, this could be a satellite image, it could be a yield map, it could be a bare ground image, and we're using a GIS software to contour that points. And so by contour, I mean group like areas and give us a map. So in this case, 5 soil samples would go to the lab. Everything that's that dark brown would go in soil sample bag number 1. Likewise, the next one, everything number 2 would go in soil sample bag number 2, all the way through to soil sample number 5. The tops of your knolls would all go in a soil sample bag. So not a bad approach. It's probably the cheapest, easiest way to measure high ground, low ground, and keep soil sampling cost low. But if you're in an area where every one of these knolls has a different pH, and you really want to begin to amend that soil and apply the appropriate amount of lime, you can't do that with this approach, because you're going to get an average. You're not going to get the accurate value of each knoll specifically, and likewise for all the other areas in the field. So again, you get what you pay for, and you really need to understand what your goals are for the farm and what you want to do. If we move to polygon-based sampling, each individual polygon is a soil sample bag. So we take 12 cores in that polygon, it gets bagged up, kept separate, and sent to the lab, and you get your own analysis or your own result from that polygon. And we do that across this field. So lots of soil going to the lab, but still, comparable and economical to a 2.5 or 1 acre grid sampling approach, no extra cost. And then we get to the soil sensor type approach, where the amount of soil that goes to the lab is low, but because the sensor is collecting things and the computer generates the model, you get, just in this green square is what I'm showing here on the screen in the large section. Each one of those dots is actually a recorded point. So thousands and thousands of points of data across a farm, giving the true resolution of each individual nutrient. Like, this is more data than most people require today or will for a long time, but it really starts to show the variability on a farm, and the cost for doing this type of approach is now reasonable and within means of the average farm customer to benefit from. So again, depending on what your goals are and where you want to take your fertility program and your precision ag data management program, this option starts to get really attractive as we move forward and as we move into the future for applying the right product in the right place, right? Because we're getting pretty specific on the place when we get into this this type of sampling. So, the first part of this presentation was to help you guys make the right decision. What type of soil sampling works best for my operation? What goals do I have? Am I just looking for a general straight rate fertilizer application to get me through the next few years? Okay, a bulk sampling approach probably is just fine. If I'm looking to get into the variable rate and I don't have much data on the farm, I don't know how to build zones, I don't have a lot of precision ag technology on my equipment, then grid sampling is an amazing place to start. That's where we need to be. It's going to give us a very good indication of the variability. It's going to help us build some prescriptions that we can get applied to the farm and get fertilizer applied in respect to 4Rs in a much better way. And we can do that without a lot of data. But as soon as we start getting, some yield monitors in the combines and a good understanding of how these trends are changing across the field, then we start looking more at polygon-based sampling and creating those polygons or zones in the right shape and the right fashion, so that we can really tweak this and really begin to create change across the operation, right? Because soil sampling is the key to properly managing our fertility input costs. We need to do that to be more productive and more competitive in the marketplace today. It's a must when we are trying to maximize yield potential within the field. You know, we need to match our fertilizer expense to the yield potential of the zone that we're applying to. We have to stop over applying low yield zones, and we need to start applying more in those high yield areas where we're potentially at a critical soil test level and we're leaving bushels on the table. We need to stop blindly applying fertilizer to a field and potentially wasting thousands of dollars of fertilizer without having any knowledge of what's going on underneath that application, right? And I know I've said it lots of times, but your soil sampling operation must match the goals that you're trying to achieve on the farm, right? Pick the right resolution, and the point of this first part is know the difference. Understand what you're purchasing and understand what you're selling to your customer, and make sure they know the value. There's nothing worse than have a customer upset with you after the process, or being a customer yourself and just not understanding or receiving value from spending the money to get something done. We're here to support the trusted advisor to help them understand and make it easy for them to get this done, and to help them collect soil in an easy and economical way, so that they can service the customer better. So when we talk about that value, let's dive a little bit into the soil test itself and talk about that. If we're a newer or a green salesperson, a green agronomist, the soil sample is a pretty daunting step. There's a lot of information here. There's a lot of timidness to making a wrong recommendation, to upsetting a customer. There's a lot of value on this sheet, and it takes a long time to understand how to relay that value back to the customer. The questions there on the right-hand side, what do all these numbers mean? How does this apply to my farm? Are all things we're challenged with from a customer every day, right? The biggest mistake we hear from all of our customers and all the customers that call us for help is, and I've heard time and time again, the number one thing we have and call we get is from customers that have a soil test data done from somebody, and they just don't understand the value when they're looking for help. So that is real. We as an industry need to do a better job in supporting the farmer and helping them understand what these numbers mean, because we get rather long in the tooth and up in our careers, and we start to assume some things and take things for granted. But we need to remember what we were like when we were fresh out of school and we looked at one of these soil tests for the first time, and a lot of our customers are in that same boat, and we need to do a good job in helping them better understand the value and what these numbers mean. So start with the simple things. Look for the low-hanging fruit. When I look at this soil test, which happens to be one of my own, these are the first 4 samples that were done on that farm we've been talking about throughout this presentation, and we'll get into here in a little bit. Phosphorus jumps off the page as being low in these first 4 samples. Obvious. We need to start working on that. Potassium's high, looks good. Magnesium's high in this case, which unfortunately is not the case in this field, but these first 4 samples are. Calcium's terrible, pH is terrible, and looks like we've got a boron issue, right? So, when I'm talking to a customer, forget the numbers, just start looking at the obvious things. What's optimum in my area? How far away from optimum is each nutrient? And what benefit is he going to get from a fertilizer, right? So in this case, phosphorus is extremely low. He's going to get a tremendous response to a phosphorus fertilizer. He needs to know that. Potassium's high. Depending on what the rest of the report looks like, yes, he needs to apply some potassium so he doesn't go backwards and lose what he has, but it doesn't need to be his major expense. Lime, pH is terrible. Lime is probably the most efficient thing and best he can do. It's going to fix the calcium. It's going to, if magnesium's bad in spots, it will help that, and so on and so forth, right? So keep it simple. Look at those trends that jump off the page at you and go from there, and work with the customer so they see the value, right? So when we do that, you know, whether we hand them that lab report or we hand them the 15 to 25 page booklet of soil sample results, explain it to them, make sure they understand what they're getting, walk through those maps with them so they can see what's happening. You know, have them understand that red doesn't mean low and green doesn't mean high. That's just the spread of the data being represented on that page. Yes, it is low and high, but it doesn't mean it's critical or excessive, right? It's just the spread of the data that we're showing the customer, right? So when we look at phosphorus on this farm, you know, you can see we're going from near critical soil test level to excessive, right? Same thing with potassium. We're not at a problem yet, but we're getting really close. And as I mentioned earlier, those low testing potassium areas are where yield's highest. We've mined the soil in those areas. And on the flip side, where potassium, maybe not excessive, but definitely in a high range, is where yield is lowest, right? Phosphorus follows a similar trend. So you can see the years and years of straight rate application on this farm has caused a natural variation in the soil based on removal alone. We need to start fixing that, and we need to stop that trend from continuing so that we can be more profitable on the farm. So when we do that, we begin to create recommendations that now make sense to the customer. They understand what they were supposed to be focusing on. They understand where the yield is. They understand where we've removed more nutrients and soil tests are low, we're putting more back. Where we're not getting any yield and where levels are high, we're saving our money and we're not applying much at all. We're actually below the 2-year removal rate. Here, we're 2-year removal plus build. You know, that's where we're generating revenue. That's where we're going to put our investment for the future, and so on and so forth. We're balancing the soil. We're fertilizing based on yield requirement. And if we want to talk economically, we're doing the right thing. We're putting the right fertilizer in the right place, and we're not over fertilizing any areas that are high or excessive. So now that we have the soil test measured properly, and you can see the different zones here, and we have the yield, and we know what's actually starting to happen, and we've talked to the customer around the easy low-hanging fruit, you know, the basics, what needs to be done, we can really start to take it to the next level. And we can actually start using some tools and some analytics to start helping us understand where our most limiting nutrient is. We've all seen Liebherg's Law of the Minimums in just about every agronomy paper or soil sampling course we've ever taken. But, you know, we really need to remember that the growth of a crop is limited by the scarcest required resource, not the total amount of resources available, right? So whatever the most limiting nutrient is on that soil test is what is going to affect yield. When it runs out, yield stops, and we need to look for that. So what on the soil test is the most limiting nutrient, right? So when we start thinking of that, we can start to generate curves that look like this. So on that field I just showed you, we can look at the entire range of nutrient. So here's our yield range on this axis, and we have our soil test levels across the bottom. So on this farm, where yield is highest, we're in that 28 to 30 part per million range. That's optimum. And lo and behold, that's kind of that standard soil test reading for our area. That's optimum level. That's where we want to be. Anything less than that, and as we get down close to critical soil test level, really starts to have a negative impact on yield. And sure, when it gets higher, there's also a yield decline, but it's not a yield decline based on too much P. It's just there's some other factor or something negatively affecting the crop. And you know, when we get this high, we don't need any phosphorus anyway, so we need to start lowering our rates and turning the application equipment off as we get into those areas and save our money. When we look at K, we see the same trend. Now, in that field, the way the test was run, our highest yielding areas were in those mine zones. And like I said earlier, we weren't at a critical soil test level yet, so we weren't getting a negative response and a yield hit, but not a trend we want to continue. This is the bump that's real. We want to be at that 165 to 170 part per million potassium on this farm to be at that maximum yield benefit, and not far enough away from the critical soil test level that when we do try to push yield, we see a positive response. I know when I push yield with seeding scripts and extra nitrogen on a really good high productive year, this area performs well. This area falls flat. I cannot grow 300 bushel corn in an area like that. We can in this area. So we need to fix fertility so that we build the whole farm up holistically, so that when we push some of those other things, we get the response that we're looking for. When we look at magnesium on that farm, the trend's very obvious. We need to apply more magnesium on most of the field. The average is below and fairly close to a critical level, and we need to fix that issue to make it better. So again, how does that work? So we draw our zones based off of yield and bare ground. We understand how the field performs year in, year out. We look at that normalized yield and we get a very nice map. We then soil test those zones, and we then start to dive down through the layers and we look at each zone. So first we look at the high yielding areas and we look at the nutrient levels under those layers. And then we look, as yield changes, what nutrients change the most with said yield change. And that begins to really tell the story, and tell us what nutrients are affecting yield and ultimately the limiting factor affecting growth. And when we do that, we create a kind of a very nice simple set of maps that help the customer understand and the agronomists talk through, what's limiting, what's not limiting, and potentially what's too high, and what should we focus our fertilizer investment on for this upcoming season, and how do we take that productivity to the next level. So from there, the last thing to do is with the customer, after we've helped them identify their zones, help them understand their soil test, worked at applying a fertilizer product on the farm, is to help them validate the application and see if there was a positive result. Now, this type of ROI calculation works very well for products that you'll see a response on in 1 year. Nitrogen seed, fungicide, products like that. It becomes a little more difficult when we start looking at phosphorus, potassium, and some of those things. To build a soil takes time. To see an effect of a fertilizer on a good testing soil is very difficult. But the trend over time is very easy to see. In this case, because boron was so low, if you remember from that original soil test, it was like 0.1 and 0.2 part per million, like extremely low. And our soil tool told us that boron was one of the most limiting factor in half the zones. I decided I wanted to try to see if we could show a result in a test and show a positive ROI. And lo and behold, it did work. So this example here shows you just about everything we've talked about in this entire presentation. So we created zones based on yield and elevation. We then soil sampled said zones. We then ran the soil analytics tool across those zones to identify some hidden hungers and identify something we may not have measured before. And to be honest, I never tested for boron previously, but decided to based on some of the literature floating around in our area, and came up with this interesting discovery and this response. So we then created a fertilizer prescription, which we have in the middle here, where yellow was applied and green were our unapplied check blocks. And yes, I was very specific and random where I put those blocks. I wanted them in the poor areas, I wanted them in the average areas, and I wanted them in the good yielding areas so I could see what happened in each zone. And here are the results. In our low yield zone, we made 23 bushels of corn from 1.25 pounds of actual boron. In our below average, 22 bushels, and our above average, 12 bushels, and on our high yield zones, 5.5 bushels, right? At the end of the day, 13 bushels of response, $60 gross profit, $21 in application and script cost for a $40 net profit in our pocket per acre across that farm, right? So this is the type of value we can create by looking for those hidden hungers, by tweaking our soil sampling operations, by understanding the value, and by using some of these new tools in the marketplace to help us better understand what we should be applying and where we should be applying it. So to wrap it up, when we think back to the beginning few maps, we're all faced with a challenge. Soil test levels are dropping across North America. There's no ifs, ands, or buts about it. Our yields are increasing from genetics, from better management, from equipment working better. I mean, you name it. We're just doing a better job of farming. Yields are going up. We need to be applying more fertilizer. Agronomically, if yield goes up, the amount of fertilizer going down has to go up also. We're mining our best soils, right? That's a problem. So soil sampling is our way to manage that. It's our way to apply more fertilizer properly. It's a way to apply it accurately. It's a way to apply it in an environmentally fashion so we don't get ourselves in trouble. And it's a way to make ourselves defendable against issues or things that could potentially arise. We're protected. We have a recommendation. We're doing things by the book. We're doing things based on proven science, right? If you can't measure it, you can't improve it. One of my favorite quotes. We must determine the variability across our farm so that we can measure it, and we can measure what's going on within that variability so that we can improve each individual area of that farm. When we think of that first map I showed with the bare ground imagery and the yield map, it's very obvious. There's more than 2 types of soil on that farm, but there's definitely 2 different management practices that need to happen in that field to be to increase productivity. And we need to accurately determine where those areas are, and we need to farm them accordingly to increase our resolution. If we continue to do the same thing we've always done, we're not going to get any different results. We must make sure we match our soil sampling resolution to the variability within a field. It's crucial in creating those positive results. Whether we use grid or zone, it's completely your choice. There isn't a right or a wrong answer. As you begin to dive into the data world, and as you begin to ask more from your service provider, and you want more from your scripts, you're probably going to find yourself leaning more towards a zone or sort of polygon-based sampling approach, or potentially even a sensor approach. But if you don't have a lot of data today and you don't know where to start, grid sampling is the best place. I mean, it's a good first step. Sure, you can start right at zone if you like. You don't need a lot of data to do so, but obviously the more data you have, the better those zones get, and you're off to the races, right? As an industry, we need to make sure the value is understood to the customer. If we're not creating clear, actionable solutions that the customer is looking for, we're underservicing and not creating the value needed, and we're doing injustice to the whole practice of what we're trying to promote. There's a lot of perceived smoke and mirrors in the marketplace, and I believe a lot of that comes from the customer or the service provider not showing the customer the value. If somebody can't show you the value and can't explain the value to you, I probably wouldn't buy the product from them. It's that simple. You want to deal with someone that's knowledgeable and someone that can create the value and help you reach your goals. That's real, and that's what you need to be looking for. I believe too often the industry assumes the customer is just going to understand, and the value is never delivered, and we need to all do a better job and step up to do that. And then lastly, when we're talking about soil tests and helping customers, start with the obvious. Look for the low-hanging fruit. Get the big glaring items off the table and help. If soil test values are all super low and the farm's in dire need of help and fertility, a variable rate fertilizer application might not be the right first step. Just more product is. It's not until you start getting into trying to finesse and fine tune and look for the options and the things to not over apply and get into those critical levels, then that's when you start using the tools. And there are lots of tools available to help you manage the more difficult, all the way up to that last tool I showed where we can dive right in to look for, where micronutrients in each nutrient is deficient by zone. And we're here to help make it easy for the agronomist and the retailer, and help them through and be that background support so that the customer gets what they're actually looking for. So I guess we'll open it up to some questions and thank everybody for their time. And Scott.
Oh, Mike. Wow. Thanks. Yeah, Mike, I appreciate the great class you've given us today, the great webinar. The amount of useful information you have given is very indicative of 99 people are still on board, and we got up to maybe 103. So it seems that most people have seen great value, and I greatly appreciate it. We've also got, I think, quite a few are watching over on Facebook as we shared it over there. So Mike, I really appreciate it. For everybody who's online, absolutely, we're opening it up for questions now. And we will go as long as people are asking questions. I've seen already we've got some questions going in, so we'll jump right to it. First question is coming from Frank, and Frank is referring back to one of your first or second slides, Mike, about the changes in fertility across North America. He asks, is the large change in Iowa soil test levels due to a change in testing methods, or do you have a thought on that?
Yeah, great question. And I don't have the exact answer. I don't know, but yes, I do have a thought, and I believe you're right. If testing methods do change, or the way a customer, the number of customers or different customers sample differently, yes, that will skew the results. But at the same time, the power of aggregated data across North America itself, I think the trend is real. Sure, there's going to be some blips here and there and some little blurps in the data, but think of the number of soil tests that happen in your state as a whole, and then think of the number of soil tests that happen across North America as a whole. And I don't believe we've changed our practices enough to change results that drastically. My belief, but I think it's real. And more importantly, if we have changed our soil sampling practices in such a way that we are learning more and we're sampling different soil tests, then all that's doing is showing us that there is more soil that is at a critical soil test level, and we're learning how to better test, and we're learning that we need to do a better job of applying nutrient.
Yeah, thanks, Mike. Next question comes from one of our favorite persons, Anonymous. He asks, why is fertilizer recommendations vary? Why do they vary, and sometimes significantly, across different companies for the same soil sample? He says this can drastically change your input costs.
Sorry, Scott, can you hear me okay?
Oh yeah, we can hear you good, Mike. Can you hear me?
Okay, I just lost you. It got really, I heard the first little bit and then it got very quiet.
Oh, sure, I'll ask again. He asks, why do fertilizer recommendations vary from different companies using the same soil sample? This can greatly change your input costs.
Sure, yes. Great question. Kind of it all stems down to the beliefs and the resources that the agronomist chooses to make the recommendation from. We see that every day. There's small changes between company and company, and there's even larger changes when we move across the continent. There are different standards from extension people versus independent. There's different methods of measuring soil fertility and response. There's the crop utilization method, and there's the soil build. So depending on the agronomist's beliefs and the fertilizer application approach they use will drastically change the fertilizer rec that goes down. I'm not going to promote any one or the other. Just I have my belief, and I know what it is. But I would challenge the listeners on the call to use the soil tests to help you prove that result. If you are a person that always picks the cheaper version and your soil test levels are remaining adequate and not dropping, then great. You're doing the right thing. You're economically applying fertilizer at the right amount and putting it in the right place, and you're not seeing a negative decline in your soil test values. But if you are soil sampling every 3 to 4 years and you're seeing a drop, then you're not putting enough fertilizer on, and that sufficiency approach might not be matching the goals you need. And vice versa. It can be the other way. If you're working with an ag retailer and they're very heavy on the build, and your soil tests are all in the good to high range, and you're still getting build results, and your soil tests continue to rise, then yeah, you can start saving some money. You need to be careful of those things. So that's where soil testing is so important, and that's where working with someone and working with your supplier to actually understand what those test values are telling you is key, so you can answer that question to yourself. You can begin to weed out what recs are too low and what recs are too high, and what the right thing to do on your farm is. Unfortunately, that takes time, and it takes a little bit of understanding, and it takes partnering with the right person to help you get through that. So.
Excellent. And that definitely gets into a philosophical question sometimes. Absolutely. Too. Yeah,
sure does.
And there's no right part of philosophy, is there?
But the science is proven, right? I mean, there is a right rate to put down for a soil test level, and that can be done. And then you get into the philosophy and the art of the the economics after the fact, and that's where you need to talk through those things with your agronomist and your supplier.
So you're saying start from the data.
Absolutely.
All right, let's go on then. The next question comes from John. John asks, and he's talking about CEC zones, and he's asking, just because the CEC zones match a yield monitor data, does this mean those zones will catch differences in fertility that are normally discovered with the more high intensity traditional soil sample levels? Again, I think he's talking about how does the more advanced sensor tools, how are they lining up with like one acre zones or 1 acre grids?
Sure. So the maps I were showing you at the beginning were just the CEC layer from the soil test. They weren't drawn based on any CEC data. Okay. I'm sorry if I confused there. So that was just the one layer, and all the other nutrients would stack up as the soil test showed just the same as that CEC layer does. They were drawn from bare ground, from elevation, and from yield. Now, if you're talking about the sensor type based fields, and the EM sleds and the CEC Veris type zones that are drawn, and soil optics, then there's a different answer for all three. And we could probably do a whole webinar on the differences in those versions. So if we talk about an EM38 type map or a Veris map, they do a very good job at measuring electrical conductivity, and if they have a pH sensor on them, they're going to give you a decent pH map as it's being pulled across the field. From there, they're using elevation data and that CEC layer to create some zones. And then they're probably, I'm making a mother of all assumptions here, so be careful. Don't take this to heart. But they're then probably going to use some sort of a contour button to create a zone map based off that EC, and then they're going to go soil sample the field off of that. You know, different companies do different approach, so please don't shoot me or pin me up as saying something wrong here, because every company is different, and I salute them for that. But just understand what you're getting when you get that. Now the soil optics piece and some of the other providers, if they're adding more layers to that data, they're doing something different, right? Soil optics itself actually is measuring every nutrient as it drives across the field. So it's measuring P, K, mag, all your micros, pH, and it's giving you, every map in the book looks different. It's giving you the actual measurement of each nutrient as it drives across the field, okay? It's also giving you some elevation and some other things, because obviously an RTK sensor, GPS is being used to drive the equipment and so on and so forth. So it is very unique and different. That's why I'm kind of curious and interested in how it works. So to answer that question, yes, the CEC is going to depict soil type changes, and yes, it's going to catch a lot of the yield variation. And if the soil sampling procedure is done properly after that, then you will get a fairly decent representation of how those other levels are changing across the field. But there is still room for error.
Yeah, thanks, Mike. Well, this kind of leads right into the next question here, and I think you've already answered it. What are your thoughts on using polygon soil sampling based on an EM38 data layer? I think you're going to say you've got positive thoughts about it.
Yeah, absolutely. I mean, I prefer polygon. That's my go-to. Now, if I could get that EM38 layer to help me draw the polygons, then, you know, now I'm ecstatic, because I've got yield data telling me a story, I've got elevation data telling me a story, and I've got the EM38 data telling me a story. And when you overlay them all on top of each other and they all line up, it's like perfect. This is exactly what I want. Now I know what this field's doing, and I'm all set. If I'm just going to use the EM38 data and contour and make some results, sure, it's a great option, but there's room for error, right? The more layers of data you can get telling you the same story to get to a more precise polygon-based operation, the happier I am as a consultant working with my customer.
Excellent, thank you. Next question, talking about boron, and you've gone into that quite a bit. John asks, on the example of applying boron and seeing a good yield response, was the soil boron measured before the application, and was there a correlation between the soil level the soil levels and the yield response?
Yes, the soil test was done in the fall, and the script was written over the winter, and the application was done with a sprayer and a Solubor type product, and it was sprayed as a blanket application pre-plant, and then incorporated along with the nitrogen, with the goal ultimately to mix it with the 28% and put it on as a PPI type thing. Yes, because we had the soil test done in a polygon fashion, and the polygons were measured based. Well, let me go back. Can you see that, Scott?
Yes.
Okay, so these are your yield zones, right? And the yield zones were a depiction of underlying fertility. I don't have the actual soil test level. That's something we could do, but yes, when we look at the hills, The low zones in boron had the highest response to the boron fertilizer application. You can tell just looking quickly here, this high yield zone on our yield map were this zone up here, and you can see it wasn't limiting. So we didn't get a response, but these zones here where the yield is low, that's where we got the highest yield response, and you can see the high yield, the low yield areas. So yes, as soil test levels drop, the response to boron went up with them, for sure.
That's awesome. Next question. Any idea of the percentage of cropping acres soil sampled every year? Just averages? Any thoughts on that?
I can't say North America wide, but I know in my neck of the woods, it's less than 20%, which is horrible.
If we're saying averages should be 3 to 4 years at the most, then we're obviously not making that rotation.
Absolutely. And the scary part is that's a field that's soil sampled. It could be bulk all the way to 1 acre grid. The percentage of fields that actually have a variable, like a high intensity soil sampling operation done with a customer following through with the script is much lower. Now, I believe that to be different in the US. I think they are doing a slightly better job of promoting soil sampling with some basic scripting. But that's and good for them. That's the right step. So the question is now, how do we make it better, and how do we make that data more appetizing so that more customers step up and want to participate?
Yeah, and we see it. We see soil test results that have excessively high fertility sometimes, and could that possibly indicate that they've been over fertilizing for quite some time?
Sure, it does. Yep. I mean, and that's not a bad situation to be in when it comes to profitability on the farm. You can cut back for a few years and go to crop removal or slightly less, or I like to think of the soil as a bank account as well, right? When times are good, build that soil bank account, put the fertility back in. And if we go through a couple lean years when things get tough and you've got some high fertility levels, awesome. Use that to your advantage. Cut back, get down to that crop removal or slightly less, and use that bank account to your advantage. So, high soil tests, borderline, you want your soil test in the good range, high end of the good range, so that you can take a lump or two, a bad year or two. High, okay. If we get excessive, you need to be careful. You're now starting to be a concern, and you need to reduce your rates and get the soil back to a more manageable level, so you're not having an environmental impact.
Yeah, great. Next question from Anonymous asks, what's average soil cost for average soil sampling where we're located? And they're basically, the question is they're in California, and their soil tests are ranging from $45 to $45, and then you add 27 for texture. I would say if you could reach out to John West, and his number is up there, and he can talk you through pricing ranges across North America, from labor costs to lab costs to there's large variations. So if you would, Anonymous, reach out to John West, and he covers down on California and our work out there, which we do quite a bit. And I'm sure he'd love to have a conversation with you about that. So thanks for the question. It's just really hard to answer without.
We need to ask you some questions first.
Right. Which leads into Terry. What frequency would you recommend for sampling?
It depends on your crop rotation and your goals, Terry. I don't like seeing a customer go much more than 4 to 5 years. Obviously 3 years is ideal and what the industry recommends, but if you're a corn soybean producer and that's your rotation, you don't have winter wheat, then 4 years is fine. Do corn soys and test on that 4th year after the soys are harvested. If you're a corn soybeans wheat guy, then I'd probably do it every 3. When the wheat's off and you've got time on your side and you've got the summer months to to get it sampled and get a recommendation and then make some decisions. That's a very nice rotation and a very nice a way to manage the data and use the data to work for you. So when you stretch out, if your farm's beautiful and your levels are good and you're not doing anything really crazy to try to change rates, you can stretch it out. I don't recommend it, but you can. But if you're swinging fertilizer rates a couple 300 pounds in a rec to try to build low areas and draw down some of your high areas, I want to know how I'm doing. I want to check myself. I want to make sure I'm not going too crazy. I want to make sure we're not sacrificing anything on the farm that's going to hurt me. So I want to tighten that up just to measure and make sure I'm on the right track. So again, it varies, but that 3 to 4 years is the standard and common recommendation. So
yeah, which leads into another one of my favorite questions, because we have this conversation quite a bit. Anonymous asks, without yield data, so assuming you don't have a good quality yield monitor or wasn't calibrated or something like that, what is the best way to determine polygons when you're trying to move to polygon samplings? We've had these discussions many times.
Sure.
What's some good yield data layers? Or,
Yep.
I'm sorry, data layers.
Yep. So obviously, yes, yield is my favorite, but it's not the only one. If you don't have that, an elevation map, RTK, if your custom applicator, if you're getting a sprayer across the field or something, they might be able to have that for you if they're using it. If your planter or any of your other equipment have an elevation layer in it, that works too. A lot of times, if a customer doesn't have a yield monitor, they probably don't have a precision type planter either. So then you're looking at, I like bare ground imagery. If you go on Google Earth, there's a little clock and arrow in the top. It's 5 or 6 buttons over on Google Earth, and you can go back through the years and look at 5, 6, 7, 8, 10 different images of that parcel of land, and you'll find a good one. You'll find one you like 9 times out of 10. And you can start drawing zones just from that alone. Again, it's only one layer, but if you're the customer and you know your farm better than anybody else and you know what the variability looks like, you can do a decent job. It'll get you out of the gate and it'll get you started. If you really want to take it to the next little bit level, you can use imagery, hire a pilot or a drone. There's lots of companies across the U.S. We do it as well with UAVs, and get your field flown. For drawing zones, I prefer to have the image like after full vegetation and before senescence. So, when the silks brown off on your corn, after tasseling, before the corn starts to really dry down, great time. In soybeans, later in the season, after full vegetation, I even like to wait after someone did, like if you're in a white mold area and the white mold sets in and starts to cause the crop to, shrink and decay and decline, that's when you want to do it, because that's affecting yield, and that's a zone you want to measure. So imagery can offer a lot of valuable insights when you pair that with a bare ground map. The longer you wait, the closer that imagery correlates to yield. And there's a lot of free sources of imagery out there now. FieldView and Circa, a lot of those companies, if you're, through your seed purchases, if you're using any of those platforms in the industries there, use that imagery to your advantage. I mean, they're very powerful tools and can help you do that.
Yeah, thanks. Next question, and we got 2 more. And wow, you guys have had some great questions. Laura asks, are there any specific crop rotations that we should focus on regarding resolution choice? And I'm assuming resolution of density of your grid sampling or your zone sampling.
Yep. No, not really. I don't find a difference. That comes down to a conversation with you and your agronomist, or if you're an agronomist, Laura, you and your customer, and the economics of the soil sampling practice. I mean, obviously, agronomically, the higher the resolution and the better job we do of sampling, the stronger the recommendation you're going to get or you're going to make for the farm. But if you're a dryland farmer, growing dryland crops, and you don't have the same economics of scale as someone under a 300 bushel irrigated corn crop, there's a big difference on what you perceive as value per acre to your farm. The crop itself doesn't really matter, but the economics does, and the amount and what you're going to do with the data does at the end of the day. The only other comment I would make around that would be if you're in an area that has extensive vegetable production and yield monitors and data management becomes difficult just because of the cropping systems that are in place. A high resolution soil sampling is crucial to vegetable production and managing the nutrients to get optimum crop and optimum quality for the plant, but becomes very difficult to manage because you may only have a crop that gives you some yield data or some elevation data or something like that once every 4 years. So it becomes challenging to see the trends over time, and as an agronomist, work with the customer to understand what's happening in the field. That's where things like imagery and elevation data and some bare ground maps really help to fill in those voids and those gaps to help you understand what resolution is going to work best for that customer. But basically, the resolution, in my mind, is indicative of the variability of the soil underneath the crop. The more variability, the more resolution you need. I mean, it's basically that simple. And then, economics drive us from there. But yeah, we got to match it to the best of our ability.
Yeah, and then John kind of follows up that a little bit. John West from us, talking about imagery and using a mid-season image to help you drive some of your zone creation. John says corn will have a good correlation of yield around if you take a good mid-season V6, V7 multispectral image, or possibly even post brown silk, you'll get some good correlations. We're not saying yield prediction, but what we are saying is some correlation of what your yield will be and how your field is performing. So that's a great image to use, V6, V7, or maybe post brown silk. And then last question we have here. Wow, great job, guys. Last question: what software would you use to create the polygons if you have multiple data layers? So what's a good software to use to pull in maybe an image, maybe a yield monitor, maybe an elevation layer?
Four. There's lots out there. The best software to use is the one that suits your operation best and the one that allows you to communicate with the people you do business with daily. That's the long and short of it. You got to have something that fits your operation. To do everything I showed you in the presentation today, we're using 4 or 5 different softwares, and that's but that's what we're here for. We're here to take that stress off of the retailer and the agronomist and the farmer, so they don't have to do it. We use ProAgrica and SMS as most of our customer facing softwares. They allow us to do what we need to do. They're not the only ones, and that's not a recommendation. That's just the ones we use, to be open and honest. We also use Esri, ArcGIS. We're using R for statistics, and a few other ones in the background to get some of the heavy lifting done when we need to. But when it comes to data layers out of equipment and a little bit of cleaning and overlaying some zones so that you can see what's going on, a Trimble, an SMS, a ProAgrica, those types of softwares that are still fairly flexible and open source and allow you to do some things are still pretty valuable in your toolbox.
Awesome. Thank you, Mike. Well, I really appreciate all the comments and questions and chats on the right-hand side from the participants, as well as participation. We had over 100. I think we had 103 in here. So this is a great event. Mike, really awesome with the information that you've been sharing with us, and we greatly appreciate it. As you can all see, we truly believe in precision ag, and we truly believe in that soil fertility is fundamental to good growing practices.